All right, how's everybody doing out there? Welcome to my channel. I'm Thomas. I do educational videos on many different subjects, mostly things you haven't heard about before that I'm trying to bring to light. And today we're doing, I think, the 24th episode on the reciprocal system of theory. And this is just the second episode on his posthumously published book from 1995 called Beyond Space and Time. Now, I'm getting a little bit frustrated because out of all of Larson's books, I think he has about 20 books, 15 to 20 books. And Beyond Space and Time is actually the only one that I actually own. Because all of his other books are free on the internet, and you can find them on various websites. But for some reason, I can't find my copy of Beyond Space and Time. And so I've been trying to update myself and read part of the book to give this presentation, but I can't find it. And I can't find a copy on the internet either. So I'm just going to be going from my notes. I have some pretty extensive notes on it, but, you know, nothing kind of replaces being able to actually look at the text for specifics and so on. So, you know, we were talking in the last episode about how, you know, Larson started with this, you know, with the basic postulates. And I do have, at least I can read those postulates too. He starts with these basic postulates, but the postulates are the result of 20 years of what he calls inductive research. And the inductive research, you know, is you know, where you're going, he says, you know, inductive reasoning is essentially a recourse to probability, an independent verification of the conclusions thus reached is essential. You know, and then after his period of inductive reasoning, he went to the deductive reasoning. And the deductive reasoning is once you have these postulates, you have these generalized postulates, you can go from the general to the specific. But the inductive postulates, or the inductive reasoning, is to going from the specific to the general. So his specifics came from his you know, kind of what you call, not his day job. You know, his day job was as a mining engineer, but at night, he, I think I read an interview with his wife, I think, and, you know, it was like he would come home from work and he would sit in his chair or his couch or whatever with a slide rule, which if you aren't old enough, you would, you know that a slide rule is kind of like a very rudimentary form of a calculator. It's somewhere in between an abacus and a calculator. And I've actually never seen one or worked with one before. But it's how they used to make calculations back in the day before calculators. And I guess this was 1930. So he would sit on his chair and mess around with the slide rule all night long, just kind of like trying to figure out, because he was looking for mathematical expressions that would explain any number of the basic properties of matter, the melting point, the boiling point of different atoms or different molecules, the melting point, boiling point, specific heat, compressibility, interatomic distance, you know, things like that. And he felt that there was a way of plugging in certain numbers into each one of the, like to basically assign certain numbers to each one of the atoms or molecules, and then be able to permutate them in different ways to get the basic properties of matter. Like, so for example, he said, I'm trying to figure out what the boiling point is, and, you know, theoretically I have these numbers for oxygen, you know, 2, 2, and -2. And now how can I plug those numbers into, you know, into an equation to get the actual boiling point of oxygen, which is probably like, you know, minus 100, you know, it's 100 degrees Kelvin or something like that. I don't know what it is. But so he would be messing around with all these numbers, and he was, I think, stumped by all this. And so he eventually kind of had this epiphany while he was walking across the street, and he more or less said that he almost slipped and fell because it was so shattering to him. But the voice inside his head basically told him, or the intuition that he had told him, why don't you just assume for the purposes of this that space and time are reciprocals of each other. And so he did that. He went home and he tried it out, and he got answers. He started plugging in these things into these equations and getting answers that were very close to the, you know, scientific observations. Okay, this is the boiling point of oxygen, and so you know, he would plug those things in and he'd get a number that was very close to the boiling point of oxygen. And he's like, wow, okay, now let me try this with carbon. He tries it with carbon and it comes up very close. So he's like, wow, okay. And then so later on, he's working on a different equation, maybe not for the boiling point, but maybe it's for the compressibility. And the voice tells him again, why don't you try that space and time are reciprocals of each other assumption again on these equations? He tried it and it worked again. And so, you know, later on he tried it again and it worked again. And so he started doing kind of a systematic investigation, and this is his inductive period where he's got this specific idea, and he's trying to apply it to these general principles. And when you do that, that's inductive reasoning, and he says it's a recourse to probability, and then you have to verify it independently. Okay, you can say, well, I plugged these numbers in and it got this number which is very close to the observed value. Well, that's not enough. That just is giving you that it's somewhat probable that this is correct, but you have to be able to verify it independently. But once he got to that point, which took 20 years or more, then he was able to kind of come up with these basic postulates. And then once he had the postulates, that's when he went to the deductive reasoning. If this, then that. If this, then that. Going from the general to the specific, where like he used the inductive reasoning to get the general, and those are the postulates. And then he started using the postulates and to apply them if this in an if this then that manner, which is what we just did those previous 15 episodes on, his outline of the deductive development of the reciprocal system. We might go a little bit more into that too, because I did find another kind of article that he had there, which is kind of called, I think it's called the step by step. And I think that one might be a little bit more pointed. But okay, so we're basically going to go back to about 1950, where he's got the postulates. First fundamental postulate: The physical universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, that's the first fundamental postulate. And then he's got the second fundamental postulate. The physical universe conforms to the relations of ordinary commutative mathematics. Its magnitudes are absolute, and its geometry is Euclidean. Okay, those are the 2 postulates that he uses to develop this whole universe. Now, so throughout his career, he used these 2 postulates to, not only do this deductive development, but to, come up with his books on the structure of the physical universe, which includes, astronomy, a book on astronomy called Universe of Motion, a book on chemistry called The Basic Properties of Matter, a book on more on physics that's called Nothing But Motion, 2 books on economics, also another book on astronomy, quasars and pulsars, The Neglected Facts of Science, New Light on Space and Time, and a few others. But here we are looking at his final book. Okay, this is his last book, which is called Beyond Space and Time, which is on metaphysics. And when he goes into the metaphysics, the metaphysics is, again, like I said yesterday, many of his kind of hard-headed scientific followers were embarrassed by his Beyond Space and Time book because his wife published it after he died, and they were like, Dewey would have never wanted this to be published. These are just his private, communications, like a diary almost, like communications with himself, musing about how to apply this to non-scientific questions. But I contest that, because Larson is saying that, this is a system of theory. The reciprocal system is a system of theory, which means if you got the theory, you can plug it into any subject. So he's trying to plug it into these other subjects. So what he's really saying, into metaphysical subjects, philosophy, psychology, religion, those kind of subjects, liberal arts subjects, and he's actually attempting to turn those subjects, put them under the jurisdiction of science. He's trying to say that these are also scientific subjects if they are approached by the reciprocal system. Because the reciprocal system, basically, it's a system. It can turn anything into a science. We can, use these kind of metaphysical social science studies, which are kind of pseudoscientific. But if we apply the principles of the reciprocal system, we can turn them into hard science. We can come up with principles that are every bit as cut and dried as, just like the principles of mathematics. And, that's what he did that earlier with his economics books. If you look at his book on The Road to Permanent Prosperity, he turns the economic situation into much more of a scientific idea, where he uses as opposed to space and time, he's using purchasing power and goods as being the kind of the two reciprocal things that are going into creating this economic motion. So he's really kind of just extending that idea here with beyond space and time. But as a result, he ends up kind of having to propose a few more postulates that he goes from. So I'm guessing that he spent a decent amount of time on the inductive phase, going back to the inductive phase here with his, he's got those two fundamental postulates in his back pocket, but he's trying to figure out how to apply it to metaphysical things, and he has to make a few more postulates to get those. And so I'm guessing that this is kind of the culmination of a long period of gestation here of inductive reasoning to figure out what he needs here in order to go deductive with it and to come up with specific answers about the metaphysical characteristics of the universe. Now, so he's got his chapter 4. Chapter 3 is just kind of an introduction of the reciprocal system. It's called the reciprocal system, and he just from my notes, he just makes a few general points. The common denominator of matter and non-matter is motion, and that motion is really like it's the contents of the universe. It's not like the container. When we normally think about space, we think about space more like as a container for the actions of the universe. But he's really saying that space and time are the contents of the universe. A substance having the properties of a connecting medium through which the various influences originating at one spatial location could be transmitted. So this is more like a motion. Motion is a substance having the properties of a connecting medium. And that here he talks about, makes the comparison of the universe of motion with a box. The speed of light, or speed, is the box, and space is the inside of the box, and time is the outside of the box. So if you have a box, you don't just have one thing, you have three things. You have the box itself, which is kind of the boundary, and that's the speed of light. And then inside the box, you've got space, and outside the box, you have time. And then he is also referring to one of the processes that, which I would guess is one of the inductive process that he's using, called abstraction. Focus our attention on the space aspect, especially because one of his offshoots of the postulates is that that we cannot see time. We only can see space. Space and time are identical to each other, but we have to basically project the qualities of space onto time, because we do not see time, we only see space. But we know what's going on with time because time is the reciprocal of space. So if we know that time is 1/2, then we also know that space is 2, because the inverse of 1/2 is 2. So we know what's going on with time, even though we can't see it. And so he's using abstraction here, focus on the space aspect, that which we can see, and deal with it as if the time aspect remains constant. So And he says this is a familiar process known as abstraction. Then he introduces the postulates, which I'll read again. The physical universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, meaning like integers, not fractions, quantized, in discrete units, and with 2 reciprocal aspects, space and time. Second fundamental postulate, the physical universe conforms to the relations of ordinary commutative mathematics. Its magnitudes are absolute, and its geometry is Euclidean. So that's where he's going. And now there's a lot of dispute about his second fundamental postulate that has been made by Perret and others in updating the theory in the 21st century. We'll get into that later. But now, now he goes to chapter 4, which is called reaching outward. So he's taking this theory and he's reaching outward. Again, this is kind of like taking the specific and trying to go into the general, inductive. And he arrives at his first metaphysical postulate, which I'll leave you with then today. The first metaphysical postulate is that the metaphysical existences, whatever they are, the elements of the metaphysical existence are likewise logical, orderly, and rational. Okay, so that is what he's come up with for his first metaphysical postulate. The metaphysical existences are likewise logical, orderly, and rational. Okay, we'll go into this a little bit more. Hopefully I can find my book sometime in the future here. But stay tuned. We're going to get into some really good stuff here. All right, have a great day.